Hello everyone, and welcome to this audio podcast. This audio podcast is part of the Calyx report edition. This audio podcast is part of a Bostix SandZtorm, and this audio podcast is part of a Squadron Communique, and this audio podcast as part of a Storm Bostix production. In this audio podcast, a little bit of an intro to works from peer-reviewed and published works from 2014, and where this works looks at nephrotoxic nephritis and glomerulonephritis, animal model versus human disease, and so thus research with animal models has highlighted the crucial interaction between inflammatory cells and cells intrinsic to the kidney, that is both fundamental and unique to the pathogenesis of glomerulonephritis. The terminology glomerulonephritis encompasses a range of immune-mediated disorders that cause inflammation within the glomerulus and the compartments of the kidney. And the mechanisms of interaction between these cells and the mediators of coordinated or part of coordinated response to inflammation have been elucidated and have been elucidated in and amongst the evidence and the literature. However, despite the pathophysiological advances, treatments for GN or glomerulonephritis remain non-specific, hazardous to an extent, and only partly successful. Therefore, GN or glomerulonephritis remains a common cause of CKD or chronic kidney disease globally. So animal model approaches offer effective and safer treatments for renal failure. Evidence of complement deposition within the glomerulus is a main feature of many forms of GN, and the role of complement is implied by several observations in human disease. Indirect evidence obtained from human investigations or studies has been supported by findings in animal models, and the mechanisms by which macrophages mediate renal injury remains to be confirmed, but it is likely to include the promotion of inflammation through the release of pro-inflammatory cytokines such as tumor necrosis factor and recruitment of macrophages and other necrosis factor and other leukocytes through the release of chemotactic molecules such as monocyte chemotactic protein 1 or MCP1, cell proliferation by release of growth factors such as macrophage colony stimulating factor MCSF, cell death through the release of reactive oxygen species including nitric oxide, and control of fibrosis and repair through the release of various enzymes. That draws this audio podcast to a close. This audio podcast is part of the Calyx report. This audio podcast is part of the Squadron Communique, and this audio podcast as part of a Bostix SandZtorm, and this audio podcast as part of a Storm Bostix production.